Hello and welcome to Merlin Tuition. Today we're going to continue our work on the reverse chain rule. We're looking at a few different examples than we did last time. We're going to start with this first question here, and we are going to, again, we're going to use our substitution, but u equals x cubed minus 7. And so we get the integral 3x squared u squared. We now want to be integrating with respect to u again. And that was because dx equals dx by du, much as we did before. To get dx by du, again, we find du by dx, which is 3x squared. We can do 1 over that, which is dx by du, which is 1 over 3x squared. Substituting that in, we have 3x squared u squared times 1 over 3x squared du. These cancel, give 3x squared over 3x squared, so you get the integral of u squared du, which of course equals u cubed over 3 plus our constant term c. We want our question in terms of x, and so it equals x cubed minus 7 all cubed over 3 plus c. Now, just like last time, we spoke about the fact that we could see a trick. This is in the form, the integral of f dash of x, f of x, to the n. And when we integrate that with respect to x, that will always go to f of x to the n plus 1 over n plus 1 plus c. And if you did want to prove that rule, you could simply do so using the chain rule of differentiation. So, when we integrate 3x squared times x cubed minus 7 all squared dx, we could have spotted that the 3x squared was a differential of x cubed. We then would have spotted it's in this form. We could have said it was x cubed minus 7 all cubed, and then we could divide it by our power and added c, which unsurprisingly again gives us the same rule. So the reason I'm taking you through this in this way is you need to be able to understand how to do these differentiations and why they work. However, if you can spot this trick here, you are allowed to do that in an exam. Okay, moving down to the second question. This second question we actually see quite a lot. It's a fairly prevalent exam style question. So here we have cos x all cubed. So I'm going to say that u is cos x. We have the integral of 5 sin x u cubed. Again, we need to change our dx to dx by du. I just made the mistake that happens to make a lot. Dx by du du. Du by dx is minus, remember your minus sign, sin x. Dx by du is minus 1 over sin x. So this is the integral of 5 sin x u cubed times minus 1 over sin x du. From there, our sin x's will cancel. And so this is the minus 5 times the integral of u cubed du, which is 5 u to the 4 over 4 plus c. Move that down. As always, we want to leave this back in terms of x. U was cos x, so this is 5 cos the 4x over 4 plus c. And as before, we could have simply done the fact that we have an integral here of k times f dash of x, f of x to the n. And what we're really saying here is that we are spotting that sine x is the differential of cos x. Obviously, it's not exactly differential. There's a minus and a 5 there as well, but we are spotting that they are differentials. And that will always go to 5x to the n plus 1 over n plus 1. We've still got our k in front, plus c. And so, when we are integrating 5 sine x cos cubed x dx, that's the same as minus the integral of minus sine x times 5 times cos cubed x dx. And all I've done here with this 5 and this minus sign is I have put it into the form k times the differential of that. So this is 5 times minus sine x, because minus sign is the differential of cos x. Now it is in this form, we can simply integrate it. That's the differential of that, so it goes to cos to the 4x over 4 over minus 5 here in front plus c, which is of course the same as we got before. This next term is slightly more complicated for two reasons. We have to deal with our trig, and we also have to deal with the fact it's not going to be an x to the n anymore because we have this exponential in there. So it looks hard, but actually, if we follow our normal steps, it's still fairly simple. If we say that u equals cot x, then we are integrating cos x squared x e to the u dx, as always, is dx by du du. Du by dx. Now cot differentiates to cos x squared, and minus cos x squared, and so dx by du is minus 1 over cos x squared x. Substituting that in, we have the integral of cos x squared x e to the u times minus 1 over cos x squared x du. Again, these cancel, so it is the integral of minus e to the u du, which integrates to minus e to the u, leave my signs out here, plus c. We don't want to have that in terms of e to the u, so it's minus e u was cot x plus c. And of course, as always, we have a rule that allows us to deal with this. What we're doing here is we are integrating f dash of x g f of x dx. Now this rule always looks a bit complicated, so what I always try and think about it as is a function, g of x, or a function, f of x. Right, just like our composite functions that we've done before. When we integrate that, sorry, that'd be a g dash of x there, sorry. So it'd be g dash of f of x, and that will integrate to g of f of x plus c. Now all I am saying here is that if I've got a function of a function like e to the cot x, and we are timesing it here by the differential of our internal function, so that's the differential of cot x, so this is saying it integrates to just whatever e to the cot x, e to the power would differentiate to, which of course is e, and it maintains the cot x. So when I am integrating cosec squared x e to the cot x dx. That is we have got here, if I write it in this form, minus cosec squared x e to the cot x dx. Minus cosec squared is our differential of cot, so it's now in this form. So it integrates to minus e to the cot x plus c. There we are.